Hello everyone and welcome to this Sunday's episode of Cosmic Revelations. Today's guest will be theoretical astrophysicist Michio Kaku, and I'm your host, Brian Cox. How you doing, Michio?
I'm doing great, thank you.
Great. How was your trip over here?
My trip over here was fantastic.
Splendid.
Very good.
Shall we begin, sir?
Very, very well.
Alright, so tell me about the Big Bang. What is that exactly?
All right. The Big Bang is not what you may think it is.
What is it then?
The Big Bang is the biggest explosion ever. It's even bigger than Hiroshima.
A Big Bang on where, Earth or where?
The Big Bang was pretty much the moment where mass came to existence. Time itself did not exist before the Big Bang. There was nothing before the Big Bang.
The
Who
Big
knows?
Bang created everything we know today.
Everything we know of.
The shirt I'm wearing, the eyelash on your skin.
The shirt you were wearing was created by some little kids in Vietnam. But the Big Bang created all the mass around the universe. Stars, planets, all that stuff.
Wow. Isn't that something?
Right.
Okay. Tell us about our solar system. How was our solar system created?
All right, now let's get this down. Our solar system was created by the remnants of a supernova. A gigantic star exploding hurled its mass, and it started forming.
So you're saying our sun, when it dies, it explodes. That's a supernova. And it
Yes.
creates
Other stuff.
planets and
Planets, see, because
a new
all these gases start swirling around over millions and billions of years. And that's what creates the planets.
I'm sorry, I just got a really funny text.
Oh,
Don't mind me.
It's okay.
Okay. Alright. Tell us, when we look up at night, we see a big black mass of white light in a circle. A moon. What is it? Where did it come from?
All right, there are many theories here, but the one that is most consistent with theory is that a piece of maybe a Mars-sized object collided with Earth and took a big chunk of Earth out, kind of like biting a Snickers.
And our planet survived this hit.
It survived it, but it was spinning it so fast that this piece of mass started orbiting our Earth, creating our moon over a million of years.
Wow.
That's one
Okay.
theory.
Right. And is it made of cheese?
Sir, it is not made of cheese.
Right.
It is made of...
What about the dark side of the moon? Are the aliens really on that side?
Actually, I am not able to tell you that because
Oh, it's top secret then. So there
it's
are
not top
aliens.
secret, but the dark side of the moon, no one has ever been to the dark side of the moon.
Right, right.
Only Pink Floyd.
So Dr. Kaku, what is the probability of life on other planets?
Alright, to answer this question, I am going to use the Drake equation, sometimes called the Green Bank equation, the Green Bank formula, or erroneously labeled the Sagan equation. Alright, and that's a famous result in the fields of exobiology and the search for extraterrestrial intelligence. You know? Alright, now, this is an attempt to estimate the number of extraterrestrial civilizations in the Milky Way, which is our galaxy. You know, crap. Now, the main purpose of the equation is to allow scientists to quantify the uncertainty of the factors that determine the number of such extraterrestrial civilizations. That really means it's a number saying, hey, how many of them might we, come in contact with,
So are these microorganisms or intelligent life that like us?
Now, I said extraterrestrial civilizations. They have to have intelligence. They have to have building capabilities,
Right.
science, tools, all
Technology.
that. Right.
Right.
All that stuff. Yes.
Understood. Okay. What about? I often hear the words black holes.
Oh, black holes are very, very interesting and mysterious
Can you see them?
objects. You cannot see them. The only way you can see a black hole is by measuring the light that's going inside of them that cannot escape its gravitational pull.
How big is the hole?
The hole is probably very, very minute, probably the size of your pee hole.
I thought it was like closer to the size of a pin.
I said the size of, I didn't say the size of your penis. I said the size of your pee hole. I'm just playing. It's very, very tiny.
Okay. Right, so I've heard a bit about the fabric of space. Can you tell us a bit about this?
All right. Now the fabric of space, it's curved. Now objects of great mass, such as our sun, these things make a dent in space-time fabric.
Really?
All right. Now this stuff right here is what creates gravitational pull.
This is why
Everything is
we
held together.
orbit the sun.
Yes, because it creates a dent in space-time fabric, which
We can't
creates,
escape.
It's kind of like, let's say, put this into perspective. It's kind of like those little things you go to the mall and you throw a penny in and you see the penny spinning around it.
Right.
That's kind of like what gravity is.
Wow.
It's a big dent which creates a curve, and then we spin around it like a little marble going down a toilet.
Right. Okay. So, what about the universe? Is it ever growing? Is it expanding?
The universe is expanding, exactly. Now, imagine this. Imagine there's a really hot chick blowing up a condom. That's how the universe is. Blowing up like a balloon.
Okay, and what about a multiverse?
Multiverse is a theory that there's not one, not two, but millions and millions of parallel universes that are existing out there with different versions of me and you.
Can these universes collide and unite?
There is no such law from stopping this from happening, but right now we're not sure. We cannot answer those questions. I am not God. I am just merely a scientist.
Right. You know, Michio, there's something scaring me to hell at night. It's a possible outcome to the fate of the universe, and people call it the Big Freeze. Can you please explain that to me?
All right, now let's talk about the Big Freeze. The Big Freeze is a scenario in which the universe simply becomes too cold to sustain life due to continued expansion. The Big Freeze is a theory of a possible fate of the universe. The Big Freeze could occur if the universe's geometry is either flat or hyperbolic, because either of those would mean that the universe would expand infinitely, causing a permanent fate. Alright?
So,
Now,
what would happen if I were to stick my hand into the universe at that
your
very moment?
hand would just completely freeze and become nothingness.
Nothing would exist.
Right, let's talk about density right now. For the Big Freeze theory to happen, the shape of the universe must be either hyperbolic or flat. If it is hyperbolic, which is usually pictured as a saddle shape, then the density must be lower than the critical density, which means that the universe isn't heavy enough to collapse under gravity. If our universe is flat, then the density will be exactly at the critical point, preventing the universe from collapsing as well. If the universe is heavier than the critical point, it will result in a shrinking universe, which leads to another theory I like to call the Big Crunch, like the Big Crunch when you take a bite into the chocolate. But anyways, for the Big Crunch to occur, the shape of the universe would have to be spherical. The problem with measuring the current density of our universe is that we cannot see most of the matter in it. Most of the universe is made up of dark matter or invisible matter in space. Ultimate fate of the universe, Big Crunch, heat death of the universe, or the Big Rip.
So, last question for today, Dr. Kaku.
It's cool, you can call me Cock for short.
Really?
It's cool.
You got that in college a lot or something?
Yes, the girls used to call me that a lot.
You had a long shaft of a space shuttle.
Yes.
Right. Okay, so a little boy from Australia just messaged us. He's asking why isn't Pluto in his brand new science book? Why isn't it included in the solar system anymore?
Oh, right. Now,
Is he a little behind the war?
yes, he's
Explain to
behind a
him,
lot.
please.
Now, this has been going on since probably 2006. Now, Pluto is way too far and is just way too small to be included as a planet. Now, it is just known as a Kuiper Belt object, okay? Because it is just a little piece of rock flying out there.
Thank you for your time.
All right.